Hi everyone, welcome back to our channel. Today we are going to understand what is the behavior of an inductor in transient as well as in steady state with an applied input as DC. So in order to understand this concept well, we are going to take a practical example. So the applied voltage I am directly taking as the applied voltage. It may be AC or DC, nothing wrong. So if you want AC also you can assume. So applied voltage is AC supply, and this wire is acting like an resistor and this fan is acting like an inductor. Okay, so therefore we are at this position, switch is in open condition and we are trying to close. This way of closing the switch from 0 minus to 0 plus is called transient. So let's try to see. There are two types of one is transient period and one is steady state period. Okay, so here we are going to be first study about transient state. So the meaning of transient state is this state is a short-lived. I mean, this is available only for short time or short interval, or this transient state is an temporary behavior of the inductor. Okay, and this will last. Example, let us take only for 1 minute. So transient state is only for short time, and it is an temporary behavior of the inductor in this case. And example, the maximum time, let's try to take as 1 minute. So now we have been closed this switch at t equal to 0. At t equal to 0 is called as a switch is just closed. Okay, so t equal to 0, switch is just closed. This is called transient behavior. When switch is just closed, automatically the supply goes to the fan. Okay, and the fan will not rotate now. So the fan will not rotate. Why it will not rotate means due to its mass or due to its inertia, it will not accept and it will not rotate. But as soon as we are given the voltage at t equal to 1 second, it starts moving. Okay, it starts propelling. So as soon as it starts propelling, automatically, slowly the fan starts running. Okay, slowly the fan is running, and whenever the time reaches 1 minute, the fan will be running with a steady speed. Okay, so this will be running with a steady speed. Let us try to take. It is runs with an RPM of 350 RPM. Here the RPM at t equal to 0 is 0 RPM. So here the time taken to move from 0 RPM to 350, the time taken is 1 minute. So therefore this period is called as a transient period. Okay, so this period is called transient period. So after this transient period, here this state is called as a steady state. Okay, so therefore you are going to have two states in the inductor. First state is a transient state and another state is a steady state. So if directly say the how the inductor behaves, we can't understand, but by this we can definitely understand. Okay, so transient state means this is a short-lived state and is the temporary behavior of the inductor. And whenever the switch is just closed, when you close the switch, the behavior of the inductor is whenever the switch is closed, the fan will not rotate. It takes some time. It is just only at 0 RPM. Slowly it will pick up 30 RPM, 40 RPM, 100 RPM, 250 RPM, and then it reaches 350 RPM. This 350 RPM is called as steady state. After 1 minute, it steadily rotates, or this will be in steady state, where the state at t equal 1 minute, the fan rotates with the steady speed of 350 RPM. Therefore, this state is called steady state. Okay, so therefore the fan moves from transient state to steady state. So this is the analogy I'm comparing with the transient behavior of the fan. Now come to our original. So this is a practical example. Now let's try to take the behavior of the inductor. So here also we applied the voltage and some resistor is there and inductor is there. So initially the current across an inductor, here we are going to get I of t is equal to V by R. So this is nothing but when you do the solution, we are going to get I of t equal to V by R into 1 minus e to the power t by tau. Tau is equal to L by R, then you are going to get R by L. Okay, so now let's try to do only in transient state. At transient state, what is the time? T equal to 0, where t equal to 0, I of 0 is equal to, so this is nothing but v by r 1 minus 1 divided by e to the power 0. Anything to the power 0 is how much? 1. So 1 will get cancelled. So I of 0 is equal to 0. So when I is 0, okay, so then you can understand that when I is 0, the inductor initially will try to act as an open circuit. So inductor is initially open circuit in transient time. Okay, so in the transient state, the behavior of the inductor, okay, is just open circuited. Now, so the same I'm saying, as soon as you give the voltage to an inductor, what it will happen is this inductor will just act as an open circuit. Okay, so this inductor at transient state, it will not operate, and just it will act as an open circuit. So here you can see here the current is 0 and just it is acting like an open circuit. But as soon as the this happen, so here I can say that inductor doesn't allow sudden change in current. This is what the meaning of the sentence. So here our inductor is not allowing the sudden change in current, is not allowing the sudden change in current. So whenever the inductor is not allowing the sudden change in current, that's the property of the inductor. It doesn't allow the sudden change in current. That's why current is 0. But slowly, when the time reaches approximately 1 minute or 60 seconds, just substitute here. So I of 60, if you substitute v by r into this, you are going to get 1 minus e to the power 60 minus 60, it is nothing but 1 by e to the power 60. Just substitute the time, automatically here you are going to get 1 by e to the power 0 is how much? E to the power 0. So 1 by 0 is how much? Infinity. So therefore here automatically 1 minus 0 you are going to get as v by r. Okay, so therefore what will exist here? Current will exist. Therefore whenever the inductor at transient state, just it will be open circuited. Later the inductor will act as an short circuit, and it will allow a current of ISC to flow through it. Okay, so now inductor is allowing to current of flowing ISC, offering a voltage V equal to 0. So this is what the behavior of the inductor after 1 minute. That's what I have been told here also. So under 1 minute it runs with 350 rpm and it is still in steady state. So fan will run. So here also, as soon as you give the supply to the inductor, so as soon as you given the supply to the inductor, it is not accepting that current, and it is making the current to become 0. That's called the property of the inductor. Later on, as soon as slowly, if you give in the form of di by dt, slowly if you apply the current, it will gets charged. Now here the inductor is acting like a short circuit, and inductor gets fully charged. Now inductor is fully charged, and it is in state of a fully charged inductor and allowing a maximum current to flow. This is what the behavior of the inductor under this case. Okay, so this is what happening. So if you have any doubt, you can just substitute here. So t equal to 1 minute, if you take automatically you can get 60. The 60 you can assume it as infinity. So it is nothing but I can add on it as 1 minus e, I mean 1 minus e to the power minus infinity, where I can write it as e to the power infinity. 1 by infinity is how much? 0. So it is nothing but 1 minus 0. So this current will flow in the inductor and it will charge the inductor. Now inductor is fully charged. Now fan is also rotating and inductor is also rotating. Now this we will try to validate with the help of a MATLAB simulation. So in the MATLAB simulation also same we are going to perform, and let us try to see whether it is happening. Okay, so this analogy is not given by any expert. Okay, so if you don't understand this analogy, this is very tough to understand. Okay, very simple to understand. So transient state, just the switch is closed, and for a short time of 1 minute, the fan slowly rotates and it comes to steady state. And steady state is running with a constant speed. At the time of 1 minute, it is under steady state. Here also, our inductor, as soon as you give the supply, it will first reject. It will say that I cannot suddenly accept this sudden flow of current. So that's why it will make current I equal 0. Later on, as time increases to 60 seconds, or just for time being I taken 60 seconds, because here also this are taken, generally it will be 4 seconds or 5 seconds. Okay, so 4 seconds automatically the current will flow and automatically the inductor gets charged. Now let us try to validate our concept with an MATLAB simulation. Okay, here also we are trying to see the MATLAB simulation. So here I have taken an DC voltage source. This is nothing but a controlled DC source. So in order to create the transient may be created due to change in load. Okay, so transients may be created due to change in load. Okay, so transients are like this. Okay, so they may be created due to change in loads, or due to variation in voltage in current, or due to switching. Okay, so due to all these variations it may be exhibited. Okay, now let us try to see here what's happening in the simulation. Okay, so here I had given an a step input with 10 volts with magnitude and applied to an DC supply, and I'm connected to an a series branch resistor of 0.5 ohm, and I connected an 1 millihenry inductor, and I'm going to show you the output. So this is nothing but the input what we are giving to the DC voltage source, and this is the output current. Okay, already we had seen how the output current is there. Okay, so this is the output current I of t. Okay, so here this I of t is given by like this. Okay, so this I of t is v by r. Okay, in this exponential this current you are going to get, and you can see the here how the current is there. Now just run the simulation, just you can have the run button, just run it. As soon as you run it, you can see the waveforms. Okay, so you will get it here. Just when you double click it, here you can get. So what is the type of input? This is the input signal we have been given. Okay, so as soon as you are given the input signal, so here you can see here. So let's try to keep in auto scale. So as soon as you are given the step signal, slowly our inductor is getting charged. Okay, so this is the time taken from this point to this point. I mean 80% of the waveform from this point to this point is the transient time. After the transient time dies out, it will go within some 0.01 millisecond. It has gone to steady state. This is blue color line is nothing but steady state. Now inductor is fully charged, and it is taking slowly, it is getting charged by the expression v by r into e to the power t by tau. Slowly the inductor gets charged. That's how the inductor is getting charged. Initially in this duration, at this time it will try to act like an open circuit, and slowly it gets charged and the current reaches to a magnitude of 20 volts. Slowly it increases and reaches that value. I can say that the inductor is now fully charged. So this is what the behavior of the inductor of an RL series circuit with an DC transient. Okay, so now under DC transient with an given input of step input with a given input, this is the input I applied. Why I had given the step means just I am giving the changing the input voltage. So this is nothing but switching. This is nothing but t equal to 0. This is nothing but t equal to 0 plus. Just before switching at this instant, here you can see here it is current is 0. You can see here the magnitude of current is 0, and current is 0. Slowly the current is reaching, increasing and reaches 20 amperes, and this time is called as transient time, and this time is called as a steady state. Okay, that's how the inductor behaves under transient state as well as under the steady state. This is what the behavior of the inductor. That's why I have been taking this example to understand. So the behavior of an ceiling fan. So the behavior of the ceiling fan, just at the time of switching and just after switching at t equal to 1 minute, the behavior changes. Okay, so as soon as you turn on the fan, slowly it oscillates. That period is called transient. That period is for short time, and that period is the temporary behavior of that inertia of that core. Okay, so due to that weight, it is unable to rotate. It is opposing that change. Okay, the period is called transient time. After the transient time, it comes to steady state. That's how an inductor acts as an short circuit in steady state. Okay, that's why inductor will act as an short circuit, and this is what the behavior of an inductor with an DC supply. Hope you are able to understand. Let's try to see like this more videos if you are interested. This is how generally to understand the subject. If you feel my content is good, please like the video and share with your friends, and if you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, subscribe to my channel with the name KV Tulasiram. Okay, so kindly support this sort of free channels for the development of students and faculty, and we'll meet in another good, beautiful concept all about the transient behavior of an capacitor.